In this paper, we introduce the DistAttention algorithm, which revolutionizes the traditional attention computation by breaking it down into smaller units known as macro attentions, MAS, and their corresponding key value, KV, caches, or R blocks. This innovative approach allows for independent model parallelism strategies and memory management for attention layers versus other layers within the transformer block. By performing MAS separately and aggregating the results, we significantly reduce the overhead of attention computation. We also present the DistKV-LLM engine, a system that integrates seamlessly with DistAttention to provide efficient KV-cache management for language model (LLM) services. This engine coordinates memory usage across GPUs and CPUs in the data center and includes a global manager, G manager, and a resource manager, R manager, for effective and scalable resource management among distributed instances. The engine proactively identifies and borrows available memory spaces from other instances when a memory shortfall occurs. To address memory fragmentation in the distributed KV-cache environment, we implement a new algorithm called DGFM. Our work also focuses on communication optimization. We overlap the computation of attention with the transfer of remote R blocks to reduce data transfer volume. By utilizing high-speed interconnect networks, we ensure efficient communication between instances and minimize communication overhead by overlapping computation and communication tasks. We evaluate the performance of DistKV-LLM and baseline systems on different context lengths in our context length benchmark. Our system achieves a throughput comparable to the baseline while supporting substantially longer context lengths, demonstrating a 2x-19x improvement. We also evaluate the end-to-end performance of DistKV-LLM on different datasets with varying proportions of long requests, achieving performance improvements ranging from 1.03x to 2.4x compared to the baseline, depending on the dataset. Finally, we compare DistKV-LLM with live migration as an alternative solution for handling varying context lengths. Our results show that DistKV-LLM experiences negligible disturbance in latency, while live migration incurs significant overhead. We also introduce the DGFM algorithm to optimize memory allocation by recalling lent memory spaces, maintaining higher overall throughput compared to systems without DGFM. Our ablation study conducts a breakdown analysis of the runtime of DistAttention and compares it with attention divided into parts by tensor parallelism, showing a 5% to 10% increase in latency due to the additional overhead of DistAttention.